Well, today we're going to take a look at some of the navigational instruments and some of the advances that happened in the technology that was used to actually guide where you were going on the oceans. And these navigational techniques actually allowed for the explorers to find more and more. And these are something that we could fit into a lot of different lessons, but it's helpful here at this point before we look at the individual colonies to see how these colonies were even possible in the first place. It's also very intriguing just to see how they solve some of these basic problems. It's something that we're not really aware of. You think about this. Do you actually know how to read a map? If somebody gave you a road map, could you actually find where you are on that road map and be able to guide someone through? We live in an age where we're so used to using something like a GPS system or using something that tells us where we're already located by a satellite that we've kind of lost a lot of skills of knowing our way around things. The same thing would be if you're in the forest. Do you know how to use things like a compass? How to use various things in the sky to actually tell where you are and find your way to, say, a river or find your way to, say, a town or something along those lines or a road? But these are skills that we often are losing, but the early explorers had to have these skills or they would quite simply die. So it's important for us to pause here and learn a little bit about this. It would also be very intriguing for you to go and see if you can research this further and figure out how they actually did some of these things. Now, the first thing I want to start with in terms of navigational instruments was the whole idea of how do you find out what direction you're heading in? How do you find out if you're heading north, south, east, or west? Now, you're probably thinking, well, you use a compass. But what you may not realize, or what you may not have thought about already, is that the compass itself had to be developed. The compass itself had to be invented. It wasn't something you just found in the ground somewhere. It actually had to be put together by man. It had to be thought through. He had to figure out how to actually construct the circle that goes around the compass that shows where north, south, east, and west are. Well, the very first compasses, as far as we know, were developed probably by the Chinese. And what's interesting about the Chinese compass is it was very simple. It's basically a bowl of water, and in the middle of it, it had a piece of cork with a magnetic needle in it. Well, when the Europeans got this technology, possibly from some kind of interaction with the Chinese, or they just stumbled across it as well, they made those magnetic needles always point north towards the pole. So they had a good idea of where they were in terms of direction at any given time. Now, this was a huge advance because prior to the compass, the only way you could tell where you were was by looking at landmarks, or if you were out on the ocean where there was no land, you would have to drop weights into the water with knotted ropes that would actually give you an idea of how deep something was. But if you were in really deep water, you may not have enough rope, no matter how much you brought with you, to actually get to the very bottom of the sea. And so the compass was a huge advance in telling people where to actually go. What's kind of funny too about the compass, and especially the Europeans, is for some reason the compass was seen as witchcraft for a while. A lot of folks tend to think, oh, the compass, it just kind of moves around on its own. There must be something demonic behind that. That's, of course, ridiculous. The compass actually reveals to us how God has made the world and how he has created magnetism and how he actually has it used in the world. As a result of that kind of ladder thinking, realizing that God actually made it this way, Henry the Navigator, whose name comes up yet again, actually required all of his navigators and all of his students at the School of Sagre to carry magnetic needles whenever they went on voyages. In fact, they always had to have extra magnetic needles. In fact, one of the tales told is about Magellan, who was the first to circumnavigate the globe. Magellan kept 35 spare magnetic needles in his pockets at all times, according to the stories written about Magellan. So the magnetic compass was a huge issue. It actually allowed you to tell where you were. But the real problem with the compass was, how do you know, you can tell where if you're going north, south, east, or west, but how do you know where you actually are? How do you know what your location is? After all, they did not have GPS to tell them where they were in terms of both space and time. In other words, they didn't have a way to tell latitude from longitude. Now, these are terms I hope you're familiar with. If you're not, that's okay. I'll quickly go over them. Latitude essentially tells you how far north or south you are on the globe, on the Earth itself. And the way you can remember that is like a ladder. A ladder has rungs that go up and down, and latitude also has essentially rungs or lines that go up and down. Longitude is different. Longitude how it tells you how far you are in terms of distance going east or west. And so longitude and latitude are the opposite of each other. What's interesting too is that latitude was much easier to tell than longitude. And let me explain that, because this is a huge part of this whole time period in history. With latitude, there's a fairly simple way to measure it. Now, it requires some what we call trigonometry, which is probably advanced math for you at this point. But latitude can be calculated this way. If you can know the time on your ship, and you just have to know the time that you've been keeping, say, with an hourglass, if you go back to the old technology, before they had clocks that could work on a ship. If you have something like an hourglass, you've been keeping track of time, what you can do is you can wait till noon, when the sun is at its highest point in the sky, and using something like, say, a quadrant or a cross staff, or later they use something called the sextant. These are all different measuring devices. They allow you to measure the altitude of the sun, how high the sun is in the sky. And because the sun is always 90 degrees above the sky at noon at the equator, you can therefore calculate how far up or how far down you are from the equator based upon how high the sun is above the horizon at noon. And you can even do it at different times of the day, because people develop charts and they develop books that told you if your sun is this high at this time, it means that you're at this spot north or south of the equator. So it's a very easy way to tell you about latitude. But the real problem was longitude. How do you actually tell how far east or west you are? And the reason that was a problem was not only did you have to have things like the altitude of the sun or the altitude of a known star or something like that and your own time on the ship, you also had to be able to compare your time to a set time somewhere else in the world. And the only way you can make sure that your time is accurate to another time in the world is if you have an accurate clock on board the ship. For a long time, there was no accurate clock on board the ship, and the reason is simple. Clocks, back in this day, back in, say, the 1600s and the 1700s, they worked off of gravity. They essentially had some kind of pendulum mechanism that required them to be in a stable place so they could use gravity to accurately keep time. So if you brought a clock on board a ship and it rocks in the waves and it's affected by gravity a little bit differently in that way, then the clock will no longer keep accurate time, and it's really kind of a worthless and expensive thing of cargo to keep on your ship. And so sailors often had to find different ways to create or to find out their longitude. One way to find out their longitude was to travel west on a known latitude, but this took up lots of time. And because it took up lots of time, they sometimes ran out of food while they were trying to find out where they were, and they sometimes died because of this. Not only that, but you could sometimes use the moon. There was a very complex way of using the moon early on, and using your measuring devices to figure out how high the moon was, and you could calculate your longitude based upon that. The problem is that while you're on a rocking ship and you're trying to figure out how many degrees above the horizon the moon is, if you're off by just a part of a degree on a rocking ship, which is not easy to do, to keep an accurate degree, that is. If you're off by just a little bit, it can cause you to be off by hundreds of miles in your calculations, which means that you may not know that you need to ration your food, and therefore you might starve. Or it means that you may not know that you're near some dangerous shoal, which you have a lookout to keep an eye out for that, but still, he might miss it because he's not expecting to be near it because you gave him an incorrect estimation of where you were. So figuring out longitude was huge. That's why in the year 1714, oh, there's a date. You should write that down. Remember, dates help us give us like little coat hooks to hang this information on so we know when it happened. In the year 1714, this idea of figuring out how far east or west you were became so important that the British Parliament offered a cash prize of 20,000 pounds sterling silver to anyone who could design a clock that would work on the ship so they could measure longitude. Because remember, if they could measure time compared to another time zone, say what the time is back in England, they could actually measure how far east or west they actually were. Now, they issued this cash prize of 20,000 pounds sterling silver, which would be like millions of dollars to us today. And for a long time, no one was able to solve it. In fact, it wasn't until 1761 that someone by the name of John Harrison actually came up with a clock that would work. It's really interesting. It's kind of brilliant how he did this. The clock that he designed was not based upon a pendulum. It had nothing to do with gravity whatsoever. Instead, he used some research by another scientist named Robert Hooke, who realized that a spring, when you stretch it, or as long as you don't stretch it too far, but when you stretch it to its given length, it'll go back to its regular shape, and it won't lose any of its original shape. So a spring can be stretched back and forth at a constant rate, and you won't destroy the shape. And so what he did was he designed a clock that works on a spring mechanism. And all of our watches and all of our fine clocks and so forth are somewhat based upon this principle to this day. Of course, we have gotten more advanced and used different techniques, but this is still one of the fine techniques. And because he did this, his clock could work on a ship. Now, the deal was the clock could not lose more than 30 seconds on a lengthy voyage. I think the voyage had to be like 1,000 miles. In order to win the cash prize, he had to take his clock on a ship, travel 1,000 miles, and he couldn't lose more than 30 seconds in time. Well, they did this. They actually traveled to Jamaica. They tested his clock, called a chronometer, and it only lost 5 seconds on the voyage. As a result, these chronometers or these clocks became common on ships. They were expensive for a while, but eventually they were common on every vessel, and thus people were able to tell how far east or west they actually were. This made it much more possible to actually found these colonies in the first place. We'll talk about the Portuguese and the French colonies tomorrow.